problem number 65. So in this problem, they told us that they were mixing 1 gram of aluminum hydroxide with 3 grams of sulfuric acid, and they want to know how much water is being created in this reaction. They also gave us this unbalanced equation, and our first step is going to be to balance this out. So when you do, you get 2 aluminum hydroxides and 3 sulfuric acids will give you 1 of these and 6 of these. So now that we have that, the next thing that I'm going to do is go ahead and find my molar masses. Aluminum has a molar mass of 26.98 grams per mole. Oxygen has a molar mass of 16 grams per mole, and hydrogen's is 1.01 grams per mole. So as a grand total, you get 78.01 grams per mole. Now I'm going to do it for water. Oh, and I multiply these by 3 because of there's 3 O's and 3 H's in aluminum hydroxide. So for water, there's 2 hydrogens, so 2 times the mass, which is 1.01 grams per mole. And oxygen's 16 again, grams per mole. Add those together and you get a total of 18.02 grams per mole. For sulfuric acid, hydrogen has a mass of 1.01. Sulfur has a mass of 32.07 grams. 32.07 grams per mole. This one is also grams per mole. And oxygen's is 4 times 16 grams per mole. Now when you add all of that together, you get a total of 103.09 grams per mole. What I'm going to do is then create my unit equations using these molar masses. So I'm going to do this one first, and I'm going to get create the unit equation of 78.01 grams of AlOH3 over 1 mole of aluminum hydroxide. And I know that I can flip that and it'll be the same thing. I'm going to do the same thing for water, so I'm going to get 18.02 grams of water over 1 mole of water. And over here I'm going to get 103.09 grams of sulfuric acid over 1 mole of it. Using these, using this balanced equation, I can also come up with my molar ratios. So that's what I'm going to do now. I'm going to have it. I'm going to have 2 aluminum hydroxides for 6 water. Sorry. Now, again, you can flip that, but I'm not going to write it out just because I know it. And you also have 3 sulfuric acids for 6 waters. So now I'm going to find how much water is being produced using my first reactant, aluminum hydroxide. So I'm going to go ahead and multiply my given, which is 1 gram of aluminum hydroxide, H3. And I'm going to first thing I'm going to do is turn that into moles. To do that, I'm going to use this unit equation, but flip it so that my moles will be on the top and my grams cancel. So I'll have 1 mole of aluminum hydroxide over 78.01 grams of aluminum hydroxide. So now my grams and my grams will cancel out, and I'm left in moles of aluminum hydroxide. Now I'm going to use my mole ratio to turn this into my into moles of water. So that's going to be 6 moles of water for every 2 moles of aluminum hydroxide. So now these will cancel, and I have my answer in in moles of water, and I'm going to have to turn that into grams since they're asking for the mass. So turning that into grams, I'm going to multiply by 18.01 water over 1 mole of water. These two will cancel, and my 6 is left. And if you multiply that all out, you get a total of 0.693 grams of water. So we don't know if that's the actual amount or not because we haven't done our second reactant yet. So doing the second reactant, I'm going to do the exact same thing as I did over here except with my sulfuric acid, So I start out with 3 grams of sulfuric acid multiplied by my unit equation over here, 1 mole of sulfuric acid over 103.09 grams. So now my grams and my grams are going to cancel. I'm left in moles of sulfuric acid. To get to moles of water, I'm going to multiply by my mole ratio, so that's 6 moles of water for every 3 moles of sulfuric acid. My moles of sulfuric acid are going to cancel. I'm going to turn this back into grams of water. I'm going to have 18.02 grams of water over 1 mole of water. Now multiplying this, these will cancel, and multiplying that all out, you get 0.831 grams of water. Now comparing the two, this first one creates less water, so that's my total amount of water that's created, and aluminum hydroxide is going to be my limiting reactant. So my final answer is that 0.693 grams of water is produced from my reaction.